Hi everyone, my name is Kaswini Ojukwu and this is my week 3 at Web3Bridge. And if you remember very well, I normally make a video of a breakdown, and I do explain what we have learned over the week. So this is week 3, and I'll be telling you what we have learned, and I'll do my best to explain them bit by bit. So as you can see from my screen, this week we learned about traditional applications and decentralized applications. We learned about digital signatures. We learned about stack, memory, and storage, which are the storage mechanism of the Ethereum virtual machine. We learned about bytecodes. We learned about opcodes. We learned also why do we use memory in Solidity when we can always use storage. We learned about integer overflow and underflow. We learned about how to avoid overflow. We learned about variable parking, and we also started writing smart contracts. So I'll go over explaining this one after the other. So first of all, we have the traditional applications and the decentralized applications. Now, our traditional applications simply refers to the normal applications we had, something like the normal website with the front end, and then you have a back end either written with PHP, MongoDB, Python, that's Django, and connected to a server that has a database and all of that, or MySQL, or the back end is written with Node.js and all of that. So that's a traditional application. And the decentralized applications is just a front end, let's say front end built with React, then the smart contract on the blockchain. So the smart contract is written with Solidity, deployed on the blockchain, and when compiled, it generates an ABI and contract address, which the front end written with React, which is the mostly used front end framework, will now connect to the smart contract with the ABI. ABI is just something similar to what we call API on the traditional applications. So on traditional applications, we call them ABI, application programming interface, and on Web3 they are called ABI, so application binary interface. So an ABI is just the structural interface of the functions and data types of your smart contract, which provides these functions for your front end whenever your front end wants to call any function that is written in your smart contract. That's what the ABI does. So your contract address enables the front end to connect to the smart contract you deployed. Then we talked about, I talked about digital signature. So digital signature is it's one of the key part of the blockchain. Yeah, it's basically used for signing transaction. Now, have you ever wondered how does the blockchain know that this person is actually the rightful owner, or the person that signed this transaction? So with digital signature, you can sign transaction. Digital signature is used to verify the authenticity of messages. Now, in the blockchain, messages are obviously transactions, and transactions comes with a couple of things. You have the nonce, you have the sender address, you have the receiver, you have the value. Some transaction comes with data and all of that. And when these transactions are signed, they have what we call the VRS. Now, the VRS is a component of the digital signature. That's the VRS, where the V is like a verifier variable that the Ethereum adds to the whole component of digital signature. So because of time, I have many other things to talk about. So I won't want to start breaking down this digital signature to the bits of it so you understand it very well. So I'll just give you a high level description about digital signature and all of that. So we also learned about stack, memory, and storage. All right. So the EVM stores data, holds data in three ways. Now we have the stack. Well, first of all, the EVM is like the heart of the Ethereum, the whole Ethereum system. So it is where the logics or the code of in our smart contract are being executed, right? So the EVM is a stack machine. Stack machine means last in first out, something like a LIFO data structure. Where imagine when you stack plates on top of each other, the last plate at the top will be the first to go out. So that's a graphical picture of what a stack is. So an EVM is a stack machine. So when you save variables in the function like local variables in the function, so they are being stored in the stack. They are being stored in a stack, and a variable can only hold a function can only hold 16 variables, right? So if it exceeds that, you hear something like stack depth exceeded, something like that. Your smart contract will throw an error. So the EVM holds your variables, your local variables in stack. So it holds them one after the other. So and all of that. So the EVM is a stack machine, and and your variables are stored in the form of a stack system. Your local variable are stored in form of a stack system. Now, when you talk about memory it's like memory is something that is not held permanently. Memory are mostly used to hold data temporarily. For instance, in a function, you mostly use memory whenever you want to pass function variable, or when you want to execute something that okay, this thing you don't want to save this data to storage, so you use memory. So once that function execution is completed, that memory is gone. So something, I think it's something related to the random access memory in your computers, that they only hold things whenever you're copying and all of that. So that's something synonymous to memory in the EVM. So they hold data temporarily for execution purposes. Now, storage is when you want to hold something permanently on the blockchain, you make use of storage. You understand? So whatever is being saved to storage, it's there permanently. Once the code is deployed, that's it. It lasts as long as forever, or as long as the code lives on the blockchain. So we talked about bytecodes and opcodes. So Solidity is a high-level programming language, and which is used in building smart contracts, right? But the Ethereum virtual machine doesn't understand Solidity. So before the Ethereum virtual machine executes this code, first of all, the codes are compiled down to bytecodes, right? They're compiled down to bytecode, and these bytecode have some opcodes in them. But the Ethereum virtual machine understands the bytecode. Yeah, it understands the bytecode. But when it wants to execute those instructions, it executes them as opcodes. You understand? We have something like push one, we have something like MSTORE, we have something like XSTORE, right? So push one, you push something into the stack. MSTORE is used to store something to the memory. SSTORE is used to store something to the storage. So yeah, I think I'll keep it high level. I'll keep it on a high level description, so we don't go down into much details. So moving over to why use memory in Solidity. All right. So you can one of the reasons why we use memory in Solidity is because using storage in Solidity is very expensive. Now one good thing about Solidity is that Solidity helps you to write codes that are less expensive. So unlike your traditional programming, you can just carry your code and start writing a lot of things. Now Solidity, you have to think. So if you can't use storage everywhere, putting a lot of your variables in storage, it's very expensive. I think storage costs about uh, two two one to 1,000 to 21,000 gas. Like putting a variable in storage, like holding something in storage, costs around 21 to 1,000 to 21,000 gas. But holding something in memory costs only 3 gas, just three gas. So you can see the Solidity is built in such a way that you can only use storage if you really want to hold something for long. Like there's no need using storage if you don't want to hold a variable for a very long time. So memory is used to just hold a variable temporarily while you're using it, and once that function is executed, it's done. So you use this to optimize gas whenever you're writing your smart contract. So moving over to integer overflow and underflow. Okay, so in Solidity, there's what we call integer overflow. So integers are marked with different sizes. You have the uint8, you have the uint16, you have the uint256. Now using uint8 for example, uint8 can the highest number uint8 can hold is 255. Now if uint8 is holding 255, let's assume you're implementing and incrementing a function, and you have 255, which is the max of uint8. And now when you increment that uint8 again, 255, when you increment, is supposed to be 256. But because that is the highest, 255 is the highest number uint8 can hold. So once you increment it, instead of going to 256, it will overflow. That 255 will change back to 0. Yes, because it can't exceed 255. That's the highest uint8 can hold. So it will change back to 0. So something similar now, bring it back. Let's say we have 0. Let's say you're decrementing a uint8, and you know the lowest range of uint8 is 0. So once you do something like 0 minus 1, it cannot give you -1. So it will take you back to 255. So that is an underflow. So that's just the difference between the overflow and underflow. So how do you avoid overflow? To the best of my knowledge, the best way to avoid overflow is to use a Solidity version that is up to 0.8, because from Solidity version 0.8, that was fixed. The overflow and the underflow error was fixed. So if you try to do any of those conditions, and which exceeds the range of the uint, or the range of the integer you specified, integer type you specified, Solidity will throw an error for you. So that's it. So coming down to variable packing. Now, variable packing is one of the mechanisms used in optimizing gas. For this, I will do a little bit of screen display, and I'll show you my screen. So let's go over to this guy. Let's look at this guy, variable packing. So if you look at my screen, this is gonna take a lot of time, but let's just do it for the purpose of learning. So variable packing here, from what we see here, in Solidity, a variable has a slot. There's what we call slot, variable slot in Solidity. And a slot has a capacity of 32 bytes. So a slot has a capacity of 32 bytes. Now, variable packing enables you to arrange your variables in such a way that multiple variables can be combined together to hold one slot. All right, now let's look at what we have on the screen. Now, from what we have here, we have address A, which is 20 bytes. We have uint 256, which is 32 bytes. We have uint 64, which is 8 bytes. And we have uint 32, which is 4 bytes. Now, from what we have here, you already see that these guys are occupying 3 slots, right? So let me do this. I'll come here and say slot 1. I'll say slot 1, and this is slot 2, and here is slot 3. All right, let's comment this. All right, now the reason why this is this way is because now the address it's an address, it's a 20 byte character, and if you notice 20 bytes, we still have like 12 bytes remaining, but because we have already started with uint 256, which is taking up 32 bytes completely, we are starting a new slot, and this slot is not yet filled, it's not yet completed. And here again we have uint 64, which is 8 bytes, and we have uint 256, which is 4 bytes, both of them making up 12 bytes. And now we have slot 1, we have slot 2, and we have slot 3, but we want this guy to occupy just 2 slots, right? So for gas optimization, so what we do now, we take these variables up here and put it here, then we remove this guy here. So now if we look, we have 20 bytes plus 828 plus 4, which is 32. So now these 3 variables are occupying 1 slot, because remember we said in Solidity a slot can take up to 32 bytes. So these 3 variables are up to 32 bytes. 3 of them together can occupy 1 slot. Instead of putting those the uint 64 and the uint 32 below the uint 256, making it to occupy 3 slots, we just combine everything here. I hope you understand, because I can't go further to explain this for the sake of time. I please, I beg you. So, but if you want to know more about slot and variable packing, you can look up that in your Google or check YouTube for more explanation and all of that. So lastly, we learned about smart contracts, we learned about variables. Okay, obviously that was where we learned about variable packing. We learned about struct. We learned that struct is a kind of a user-defined data type. Yeah, if all the available data type in Solidity, the predefined can't hold what you want, you use something like struct to create your own user-defined type. We talked about mapping. Like mapping is like a key value kind of a data type. Yeah, something similar to what we call a hash table or hash graph. So the key value kind of data type. We talked about constructor. Constructor in Solidity, it's is a function that runs once your contract is deployed. So yeah, it runs once. Anything in your constructor is run once your contract is deployed, and that's it. So yeah, I think, well, that's the end of it, obviously. Thank you very much for watching. So far so good. It's been an awesome experience here at Web3Bridge. We are actually getting more intense, and it's becoming very exciting. The whole smart contract, Solidity stuff, meeting people, and a lot of people from different areas of life, writing different programming languages and learning from everyone. So I will keep doing this, and thank you for staying up to this point, and peace out.